So now we are on our coding screen, and here we will take an example on Python which will explain the singleton design pattern. And here we will take a threading example where we will use the threading pool, and with the help of threading pool we will run multiple tasks or multiple threads, we can say asynchronously. So we will take threading library in Python. Let's say import threading, and next we would require thread pool executor, and for it we will import it from concurrent dot futures. Import uh, thread pool executor, and now we will create a class for thread pool executor. So our class name is, it's so we will take a thread manager. So thread manager, so we will create a class. So first we will create a simple thread pool executor system. After then we will create or we will implement a singleton design pattern into the same. So here we will take a constructor def underscore init, and here we will take our self comma, we will take a keyword which will required in thread pool executor. So here we will take max workers equal to, so we can take any number here, let's say 546, and here we will set our executor. So self dot executor, so we will take our thread pool executor. So here our max workers, so max worker equal to max workers. So we have taken use this keyword. So in the thread pool executor, this is our default keyword max workers. So same I have declared here. So now our next function would be submit the task. So we will create def submit tasks, and here we will take self, then we will take a task function comma, and we will take argument and then keywords. So now we will return self dot executor dot submit. So we will submit function comma, we will submit all the arguments and keywords, and our last function in this class will be shutdown. So shutdown will help to stop our execution, means our task execution. So self, so here self dot executor dot shutdown. So here we will take some keyword wait equal to true. So it will help. So when we will click on shutdown function, or we will call shutdown function, so it will wait until all the tasks finished. So now here we will take a function which will act as a task. So it's simple task, and here we will pass the number of that task, and we will print let's say starting task, and here we will give the number. Let's say first task is starting, and after it we will sleep it for some time. Let's say for 2 seconds or 3 seconds. So we will import our time library. So here time dot sleep, let's say 2, and we will end the task with the numbering. So we will call this function multiple time. So multiple task will run in the same thread pool, and utilize the same resource. So that's why we use it. So here we will end it, ending task. So now we will take, so we will make this page as a kind of a module. So here we will take if underscore name equal to underscore main. Now here we will make object of our thread pool manager. So thread manager, so we can take it thread pool manager. So you can take any name, so it should be meaningful. So here I will make a first object pool1 equal to this manager, and here we will pass max worker. So here if we don't pass anything, so it will take the default workers, but here we will pass something. Let's say if I'm passing 3 workers, so 3 workers will handle our threads, and in this pool I will take uh, futures. So futures, it's a object is coming from, let's say, concurrent dot futures. So it will contain all the thread instance in a list. So how it will contain, so let's say item for item in range. Let's say I'm taking 5 range or 6 range, so I'm submitting 6 tasks. So here I will take the pool, and in the pool dot submit task. So submit task, I am calling this function, and in this function what we would require, we will require a task function. So task function is this simple task comma item. So it's a numbering of the task. So when it will iterate, so one by one it will submit the task to the pool, and we can check in the futures way. Futures list means how it is creating the object and what is the state of the object. So if I save it, so it is clear. So let's run the page. So let's come on our PowerShell. So here we will use Python. So our page name is, module name is task.py. So we will run it. So it is running, and in the futures you can see each task state. Let's say here it is running, pending, but, and also let's say starting task 0, here 0 task started and here ending. So it is working as a asynchronously. So it's a threading feature in Python, how multiple thread we can handle. But now we will see how we can implement the singleton design pattern. So to implement the singleton design pattern, we will create a class which will act as a meta class. So we will create a class meta. So singleton meta. So we will create singleton meta, and let's say I'm taking pass, and here we will pass meta class, and like this we will inherit it. So let's, so we will take some private variable. Let's say instances. So we will take a dictionary and we will use it with the log. So we will take a private log. So log we will import from the threading. So it's a thread shape. So while log will be applied, then we will use this class. So like this. So now here we will take a call method. So underscore call. So as you know, this method call when we our object creates, so it is not related to any object instantiation. So here we will take some parameters like cls. So cls is the first parameter while using call, and then we will take arguments c and then keywords. And here we will use with statement with the log. So here cls dot log, and here we will check the instance. If cls not in our instance, so it's cls dot instance. So when our object is not in this list, then we will create the object. So in the singleton design pattern, it will avoid the new object creation. So here we will use cls dot instances cls equal to super. So we will use super keyword. So you can learn it more about in the next video what is the use of super, or I have already created some video as well. So we will take cls and then so cls with the instances and sorry, here we will use the call method, and here we will pass our arguments on this. So with the help of super, we are going to create an instance, and we are assigning on this as per class instance, and then we will return. So we will return our class instance. So when it is not available in the instance, then we will create, otherwise we will return as it is. So it is complete. So let's save it. Now we will come on our PowerShell and then run it. So with log, it is giving some error. So let's check. So here we are using the log cls with log. Okay, so it's a function. So now our code is running. So here we will check how singleton is working. So let's take some create some another object for the pool. So pool 2, and we will use the same. Let's say if I take workers some different, and I will print pool 1 comma pool 2. So here we will give some description, printing pool objects, save it and run. So here printing pool object. So here our object is 7fc8, next object is same. So here we are creating the same object, whether we are creating the multiple object, but it is creating only single instance for the pool. So if I remove this, so if I remove this class here from here, meta class, and save it and rerun it, so it will create different object. So let's see, yeah, here. So our 77 FC8, and here it is different 2595 or F48. So this is the benefit of singleton design pattern. So with the help of singleton design pattern, we can let's say utilize the resources, let's say with the well manner. So we can avoid the creation multiple instance again and again. So that's the benefit of a singleton design pattern. Thanks for watching.